There we go. Let's take a look at what we've got going on here. Hopefully you guys had a wonderful weekend. So cool out there. Did anybody travel, do anything over the weekend? Go anywhere? Where'd you go? Arizona.
Yeah, my sister got.
Oh, so cool. Arizona. Love it. Anybody else travel, go anywhere? Where'd you go? Where'd you go? Where'd you go?
I go on a date in Taylor's Prius. That was a hole in it.
Yes.
Not a hole in it, it has a hole.
Yes. You went to the. Oh, you went to Dayton to go watch the football at Welcome Stadium. So good.
Yeah, it
Scored and scored and scored. Well, good. Did anybody go watch the fireworks downtown Cincinnati? Anybody? Does anybody go down there?
no.
Fireworks in Cincinnati once a year? The big ones on the river? No. Okay. All right. Hey, let's come back here and take a look here. We're going to do some linear equations. Remember that all the way back in Algebra 1?
Yeah.
Linear equations. Love it. Love it. Okay. So we'll go way back and take a look at what happened back there. Just a quick reminder, a linear equation is any first degree equation. In other words, it just has one variable, and that variable is to the first degree. Okay, it takes the form of y equals mx plus b. Now, it could be the good old y equals, we could have like a negative slope on that. It could be a fraction. Anything like that. What we're not talking about when we do first degree are the y equals x squared, or even a y equals the square root of x plus or minus something. Okay, so those are a no-go. Let's take a trip down memory lane. Remember solving these way back at the kiddie school? Who had math teachers in the kiddie school? Who was your math teacher? Who was your favorite math teacher in the middle school?
Miss Cummins.
Miss Cummins. You had Miss Cummins. Oh, yes. Laid back, funny. She, yes. I have a joke book back there that I used from her, but I can't tell them as good as she does. So
I love that.
he's great. Anybody else? Who had Miss Dorson? Anybody have Miss Dorson? You had Miss Dorson? Oh, you had Miss Dorson? You had Miss Dorson?
Oh, no, I'm saying I'm friends with Miss Sandra on Facebook.
Now, Miss Dorson is one of my favorite students. Yes. Yes, Miss Dorson sat in here just like you. And you know what? Miss Dorson sat right by this guy.
That's right.
And you know what that guy's last name was?
Dorson.
Dorson. So, be careful who you're sitting by. It could be a lifelong study buddy. Okay. So,
Who's thinking best?
yeah.
Thinkers.
Really check out the field, ladies. Okay. So, yes. So that's how wonderful and lifelong. But hey, when you had Miss Cummins, Miss Dorson, or whoever, Miss Lake, any of those. Okay, remember seeing these and even drawing that line down the middle. Okay, and then which one are we going to move? And you said, oh, let's move the 3 because we want a positive coefficient here. Subtract the 3x from both sides. That left us with 4 equals 14x minus 9. Now that we've got the x's all in one spot, we want to get them by themselves by adding the 9 to both sides. Once we've added 9 to both sides, we'll be left with 13 equals 14x. And then, of course, to get the x by itself, we need to divide by 14. And in the end, you might even take another look at it, make sure you did your math right, because you didn't get a lot of fractions, but in the end, if you did get a fraction and you did your work right, that was all okay. Okay, so that was back there. Then you come over here and they've got this mess going on, which requires a few more skills than just the moving from one side to the other. And that, of course, was the foiling, combining like terms, all that type of stuff that we learned and had to do here. So let's go ahead and foil this first. We know that the first is going to give us a 2x squared. And then we always do the outer and the inner in our head. So negative 2x minus x will give us a negative 3x. And then we'll be left with just the negative 1 times negative 1 or a positive 1. Okay. And then we repeat the process on the other side because we have some foiling to do. The first term will give us a 2x squared. And then our outers and inners will be a negative 5 minus 10 or a negative 15x. And then the negative 5 times negative 5 leaves us with a positive 25. And then we're going to do the same process of getting the x's on one side, starting with the highest degree, the 2x squared. Ooh, that takes us right back into a linear equation. When we get rid of that, even though this wasn't technically a linear one, it ends up being solved like that. So we know that those two are going to give us 0 on both sides. So we can move and even this time we have a little trick with this one. So rather than add the 3x, we choose to add the 15x to get the positive coefficient. And the next line might even look like a 12x plus 1 equals a 25. Subtracting the 1 from both sides, we get the 12x equals 24. Dividing by 12 leaves us with an x equals 2. Happy, happy, love it. Okay, so middle school, freshman year-ish. Now let's jump to Algebra 2, college algebra, and let's solve rational equations. So some of the same skills we're going to have to do. We're going to have to keep both sides equivalent to each other. We may have to do a little distributing. But since we do have rational functions, again, what's the first 5 letters of rational spell? Ratio, or another word for ratio is? So we've got fractions, which now when we're solving these, we do need to be careful that we have a domain that is, or our answer is within our domain. So first thing we want to do is establish the domain. And our main issue here with domain is that our denominator cannot equal 0. So let's do that first. And then the skill that we just practiced while we were doing our opener and check on our work with the homework that we had is we want to multiply through by the common denominator. Okay. We may end up with a problem that, say, looks like this. Or this may have been a problem you had in algebra, say 5/4 of x, say minus 1/5 equals 7/10. Okay. Now, could we add 5/4 to both sides? Could we divide by 4/5? Yes, we could, but we learned a little trick, and that was clean it up by getting rid of the denominator. And what could we multiply both sides by to get rid of the denominators altogether? What, anybody see it? Okay, multiply both sides by to get rid of all the denominators. Anybody? Boom. 10? A little better choice than the 5, right? So yeah, so that's in essence what we're going to do with the rational expressions. we're gonna say, okay, let's just get rid of all our denominators. And you can see from this one, once we get that, this would be 2 times 4x or 8x. And then 2 times the -1 or -2. 10 divided by 10 goes away and we have 7. And now we're back to a middle school problem just by getting rid of that denominator. Okay, so, and that's kind of this last step is once we do that, then all we have to do is solve, right? Once we get it to this form, once we get rid of our denominators, and just do the basic math that we've done before. Okay, so let's start off with this first one here. First of all, let's do the domain work and get that out of the way. So in this case, we see this denominator has an x minus 2 in it. That cannot equal 0. Only way that's going to equal 0 is if x equals 2. So we're going to start off by saying, hey, let's make sure that x cannot equal 2. Okay, take a look at the next term, and this has an x minus 1 in the 0. That can't equal 0, and that's always going to be when x equals 1. So x cannot equal 2, and x cannot equal 1. So if we get a solution that's x equals 2 or x equals 1, we're going to say that solution will not work for us. Okay, so we're going to treat this exactly like we've done the other ones when we did some simplifying through, and that is, let's look for the common denominator. I've got it here and I've got it here, and that is our x minus 2, and also the x minus 1 is in 2 spots. So we're going to have to multiply both sides by that common denominator. We're going to multiply it by the x minus 2 and the x minus 1. Okay, just like over here, we could have just multiplied it by 5, but we would have still had 2 in the denominator here. We multiplied by 2, we'd have 5 in the denominator here. So we're going to choose to multiply everything to get rid of all the fractions in one step. Okay, so this is kind of like distributing or foiling this across as we do this. But you can see when we multiply this by the left-hand side, we have an x minus 2 in the denominator, x minus 2 in the numerator. So our first step is going to give us 3 times what's left, and that is the x minus 1. Then we're going to jump to the other side. And I know most of our math teachers do put this on one side. Some of them do write it on both sides to emphasize that. Whatever practice you're already familiar with, you can do. I'm okay with writing it like this. If you want to write it like this, to, hey, I'm multiplying this side by that, and I'm multiplying that side by the same thing. I'm not too hung up on how you show that, but make sure you are multiplying everything by this. Okay, now when we multiply here, what cancels out this time? Yeah, the x minus 1 goes away, and this is just 1 times the x minus 2. And I do like this one as far as getting done with it right away, because now when we multiply this last term, the x minus 2 and the x minus 1 both go away, and this just becomes plus 7. And now we're right to a problem we could just take over to any of the algebra students, and they should be able to solve this. They've already done this year, distributing, combining like terms, and solving. Okay, so of course we get the 3x minus 3 equals x plus 5, and then I think we're good enough here to know that we've got to subtract the x from both sides, and we're probably good enough to know that since we're moving the x's to the left, our constants all have to be moved to the right, so we can just go ahead and add 3 to both sides. We don't have to show this as 2 steps, even though it is. In the end, we get 3 minus 1 is 2, 5 plus 3 is 8, and then we'll do the dividing by 2, and we'll get x equals 4. Before we circle that and say life is good and wonderful, we always need to check. Make sure this is in our domain. 4 is not 2, 4 is not 1. This is good, and that's our answer. Let's take a look at our next one. This one's probably going to be a little bit easier because we only have one denominator. We just have the x minus 1, right? So let's take both sides and multiply it by the quantity of x minus 1. Okay. So remember, this has to be distributed to both of these. Oops, I'm jumping. I need to do my domain, don't I? Domain, quite simple. X minus 1 cannot equal 0. So in this case, if we get an x equals 1, it will not be a solution because that's not in our domain. All right, let's distribute this out and see what we get. Multiply over here. Oh, in this case, we have a denominator that matches this. So the first term simply becomes what? A little bit louder. 3x. And then not plus 2, but plus 2 times the quantity of x minus 1. We come to the equal sign, but that's not going to slow us down. We're going to do the same thing on the other side. And this one also has a numerator of, or a denominator of x minus 1. Simplifying this just becomes 3. Do the fun algebra, distribute, combine like terms. 5x minus 2 equals 3. Add the 2 to both sides. Divide by 5. X equals 1. Oops, I didn't check, did I? Better not circle that unless I check it. And this one only works if x equals 1, but we know we can't have a 0 in the denominator. X equals 1 is not in the domain. So this is a no solution. Okay. Say this is not in the domain, so it's no solution. Or remember, we have that little shortcut. We can just do the circle with the lines through it. That means the same thing as writing no solution. All right, let's go to the next one. Domain. Brent, what do you think the domain is this time? What's going to give us a 0 in the denominator? Will 2 ever equal 0? No. What about x squared? When would x squared ever equal 0?
0.
X is 0, right? Doesn't matter if we square it, it's still going to give us 0. So in this case, x cannot equal 0. It's the only restriction we have. Okay, love it. And then, Grip, what are we going to multiply both sides by to get rid of our denominators? Not only 2, but x squared, right? Okay, the 2 is going to be taken care of with this. Okay, so I multiply the left-hand side, the 2 goes away, and we just get the quantity of x plus 3 times x squared. Okay, now let's take a look at the other side. And Wyatt, what goes away this time? Yeah, because the x squared cancel each other out. They become 1. So on the left-hand side, this is just 2 times the quantity of 2x plus 6. We should be able to take it from here. You can see we'll have an x cubed plus 3x squared. And on this side, we'll have 4x plus 12. Okay, now this is going to change a little bit from our linear solving. Okay, remember when we did the linear ones, we just got x by itself on one side, all the numbers on the other side, but this has a higher degree of just x. So in this case, anytime we have a second degree, third degree, fourth degree, or so on, we need to set it equal to 0 and solve that way. Okay, so again, easy when we have linear, just if the x's by themselves and numbers on the other side, it solves it. But this one, we're going to have to move all of this stuff over here to the other side and write this as x cubed plus 3x squared minus 4x minus 12 equals 0. And we're solving this. We're finding the zeros. Okay. So, Kayla, help me out here. When I do this, this looks like four-term factoring, right? What can you factor out of the first two guys? An x squared. What will we be left with? X plus 3. All right. Say a prayer here. We need x plus 3 out of these other two. So, Annalie, what would we have to factor out of negative 4x minus 12 to be left with x plus 3? Negative 4. Let's check. Negative 4 times x is negative 4x. Negative 4 times 3 is negative 12. Yep. We got it. Good. Our next step is then to factor out that x plus 3. Okay, remember, some of you still confuse this and put this as x plus 3 squared. It's coming out of both of these as just x plus 3. What we're left with was x squared in the first set and then minus 4 in the other, which does continue to factor to x plus 2, x minus 2, x plus 3 equals 0. Now we can solve each one of those by saying x equals negative 2, x equals positive 2, x equals negative 3. A quick check. None of these are zeros. Therefore, we have 3 solutions. And that's it. Love it. Love it. All right, now let's let technology take over. Let's let our calculators take care of this. Okay. So hopefully we got them charged and running and in working order. If not, we'll walk you through this. Okay. So now, as we go through this, I'm going to take my time, try and explain this as best I can as we do these, because you may be very proficient with this calculator, but you may not be like somebody else in the room that's not so proficient with this. So I'll just kind of walk you guys through everything, and we'll get this down and dirty. Okay, so when we do this, we're basically looking for a solution of these equations. So take a look at this first one here. We've got a 3x plus 4 and a 17x minus 9. Okay. Way we solve these using our calculator is we're going to graph each one of these equations. We're going to take this equation here and we're going to put it in the y1. You can find that by going to the y equal button. Okay. On our calculators up here at the very top, these are the ones that give us added functions and make the graphing calculator what it is. Okay. The rest of these down here in and of themselves are pretty much like you can get on any general scientific calculator. It's these buttons up here that we're going to use to our advantage. So we're going to go in the y equals, and if you have something already in there, you can press the delete button, and wipe out everything one at a time, or you can simply press clear and it's gone. Okay. So if you've got anything in there, just press clear, it's gone. If you only want to modify a little bit, you may want to just take out one at a time. But we're going to go in here and go 3x, this second row of these buttons here. There's a button that has an X on it and then a bunch of gibberish type things. That's the variable button. Anytime you press it, it's going to give you that variable. Okay. And look at our equation. This is plus 4. We're going to put that into y1 and on the other side of the equal sign, that's our second equation. We're going to put that into y2. So you can arrow down up here at this little circle thing. You can arrow down or you can press enter to go to the next line. And in here, we'll do exactly what it says, 17x minus 9. Okay. Now, when we solve this, what we're actually doing is we're going to graph both of these equations, our y1 and our y2. And then we're looking for this point right here. That is going to be the intersection. That intersection will have an x coordinate and a y coordinate. This x equals number, that is our solution. This x equal number is our solution. So let's go ahead and graph this. Now, what I'm going to ask you to do is look at these buttons up here. Yes, I know there's a graph button, but there's also a zoom button. I'm going to ask that you press zoom, and you have a ton of selections to choose from. We're going to choose the standard. So you can press 6, or you can just arrow down until you get to 6 and press enter. And you'll see that we have a graph. The graph has the y1, in our case, it's in blue, and the y2 graphed here. Okay. Now, the reason I ask you to use the zoom 6 is because when you zoom and you choose the 6, it gives a standard layout. That standard layout has an x maximum of 10, x minimum of -10, a y maximum of 10, and a y minimum of -10. And let's face it, didn't just about every single problem you had in algebra and algebra 2 fit on a 10 by 10 grid? Okay, so most of the solutions are that. That's why it says, hey, just hit standard. Most likely it's going to fit on that. Okay, will it always fit? No, absolutely not. We are going to have problems that aren't going to fit on that. I guarantee you. Okay, but let's start there. Okay, now we need to find this point here where they intersect. And no, we're not going to just kind of move this arrow, this little Frogger thing up and try and match that point there. We're going to use the calculator and the functions that it has. Okay. So once we zoom it, and also I forgot to mention, the reason I am zooming it is because I want to make sure I see this intersection point. If I don't see an intersection point, this calculator will not get it for you. I'll repeat that. If you don't see an intersection, this calculator won't go and find it for you. You have to go find out that there is an intersection if there is one. Okay, so let's find that intersection. And what we're going to do is we're going to choose the, up at the top, you'll see that there's a trace button. And above the trace, it says calc. Okay, we're going to use the calc function out of this. And calc simply just means to calculate. So in order to do that, we'll press second and above the trace, calc. And you'll see we have these options. And from this, we're going to use option number 5, the intersect. Option number 5 is always intersect. So second, calc or trace button, get to that. And then again, we can arrow down, or I just press the number 5 and it automatically gives me the selection. Once we do this, you're going to see that it starts blinking here somewhere on the blue line on mine. If yours isn't color, you can still find it. It's there. And it reminds you, not only is it the blue line, but you'll look up here into the upper left-hand corner, and it gives you a y equal, and it shows you that function that you put in there. Okay, so up there in the corner, you can quickly see that. It's saying, hey, is this the first curve? Is this the first line? Is this the first equation that you have? And all you have to do is press enter for yes. And it immediately jumps to our second one. Oh, ladies and gentlemen, All I did was press enter. This is, oh, yes. We should have brought roses, shouldn't we? Must be a very special person to get 2 happy birthday songs. Wow. Oops.
No, I think so. No, you're here.
A Fred and Ted production. The free bus travel. Oh, it's from the UK. I don't know if I trust them. There you go. Woohoo! All right. Hey, where were we? I think we were looking at this, and we said, hey, look, it's starting to blink on this second curve. Look up here in the left, you'll see it says Y2. And if you have colors on your calculator, it will also match that line also. And then we press enter. Now, the most useless thing on a TI calculator is this thing called guess. Why do we want to guess? Just do it, right? It shouldn't just jump to it. But you get this guess on these, and don't worry about it. Don't move it. Just go ahead and press enter. And immediately, what does it do? It jumps right up here to that intersection point. And take a look down here where the x value is. It gives us the x value of this equation. And that is our solution. X equals 0.928. And let's do what we did in Algebra 2 and just truncate 3 decimals and then stop. Don't worry about middle school rounding 5 up and down and thing. Let's just truncate there at 3 decimals. Okay. So that's all we got to do. All right. Let's take a look at our example number 2 that we did. Okay. So let's go back to our y equals. And I'm going to clear this out. And I got a choice here. I can do the algebra, distribute this and put it in, or I can put it in as is. I'm going to just put it in as it is, just so I don't make any silly algebra mistake. Let's just put it in with the parentheses, and the 2x minus 1, close the parentheses, and then open it up for the next set and put x minus 1 in there. That is our y1. Then we'll put the other one in the y2. Okay. Press enter. It jumps down. Another option I do want to show, since you may not be that familiar with your calculator, is I could just start typing if I wanted to. Now, this is dangerous if my new equation didn't eliminate all the things that were in there before. But in this case, I'm just typing over what was in there and didn't have to press delete or clear. I'm going to take one more look, make sure my equations are in there correctly. And just out of habit, I'm going to press zoom 6 in case I've messed that up. And then do we see an intersection? Indeed, we do. We should see that we have 2 parabolas that intersect right here. There we have it. Okay. And we'll go to the second trace or calc button. 5 is the intersection. You see we're blinking here on the blue. That's our first curve. Blinking on the red. Oops, I don't see it, but I do know it's way up here. It says y is 25. I know I only went up to 10 when x is 0. If you're not sure, you can always just do the little arrow button to make sure it's there. Now you see it. Enter. Don't worry about guessing. Press enter. And indeed, it gives us this point here. And at this point, x equals 2. Now, it also gives us a y value here. In just solving this, the y value doesn't really matter to me at all. But there will be cases when we solve this that we do want to know what the value of the function is, and that is simply by just finding the y value that's written here. Okay. All right. I'm going to skip and just jump to this one. I think we're probably okay with entering that in. I don't see anybody stopping me saying, oh no, I didn't get that. So let's go back to our y equal. And this time, this is what's going to be in our y1. This is what will be in our y2. So I'll press clear, get rid of that mess, and I'll put in 3x divided by x minus 1, and then add 2. Then we'll go down here, clear this out, and put 3 divided by x minus 1. All good? All right. Now, let me do my zoom 6. Or no, just plain old zoom. I'm pressing the second. I need to go zoom and 6. That's interesting. I don't think it should look like this. You go back and look at my y equals again. Why isn't that graphing it right? Oh. Are parentheses important here? Parentheses are huge now, okay? We, right now, order of operations, it's basically taking these x's and canceling them out and just says this is 3 minus 1 plus 2. 3 minus 1 plus 2 is 0. Okay? Or I mean 4, okay? So it's just setting it at 4. That's not what we want. Same thing down here. This is only taking 3 and dividing it by x and then subtracting 1. We need to take 3 and divide it by this quantity. Okay? So while I'm at it, I'm just going to show you also something, again, depending on how much you use your calculator, you may not know this, but when I get over here, I want to put a parentheses in front of this. Now, if I start typing, it's going to type over and I have to retype everything. But if I just want to add this in here, I can press second, and above the delete button, you'll see it says INS, and that's for insert. And when I do that, it's going to not type over, but it's going to insert the parentheses in front. And I'll do the same thing when I go over to this side. I want to put that in front, that parentheses in front of the plus symbol. So I'll go second, insert, and put it in there. Just saves me a little bit of time. Okay. So, but again, I want to reiterate to you, just because it doesn't have parentheses here doesn't mean your calculator can go without having them. You have to tell it when it divides, it should have already done the x minus 1 first. It doesn't know, it will not avoid the case of order of operations and do the division before the subtraction unless you put the parentheses around it. And the same thing on the other one. This is not going to be the correct equation. So again, I'm going to go in here and second insert, put the parentheses in front, and then I'm going to close the parentheses on the back side like this. Now, when I zoom 6, I see something that does tell me what we should have. Okay. Now, do you see an intersection? I really don't. Okay. So we have an option here. There is one option, and that is zoom and go out. It's not as good as your Google Maps where you zoom out, zoom out, zoom out, and then can kind of move things around. It's not that good. I really would encourage you not to use the zoom out. So in this case, we're going to check our window. And you can see our window is negative 10 to 10 on the x's, negative 10 to 10 on the y's. I'm going to leave the 10s as they are on the x-axis, but the y-axis, I'm going to open it up a lot. I'm going to go down here and I'm going to jump as high as 100 and as low as negative 100. So I'm just going to go in here and open the window up top and bottom and see if we can see that intersection. Okay, now I'm not going to press zoom 6 now because then it's going to wipe this away. I'm just going to go to the graph and click on the graph. And now what you see is, ooh, this is kind of hard to actually see. And to be honest with you, unless I have Desmos, I probably can't really keep zooming in and try and figure out where this is. But hopefully what you can see is there's an issue here at x equals 1. And this, as you recall, was that case where we found no solution to this. Okay. But just to check this, I'm going to go ahead and do the second calc intersection 5, blue one, red one, don't guess, and then press enter. Okay. And every time you get to a spot where there is no solution, there's no intersection on it, even if we keep zooming out, trying to see if they cross each other, it will give you this error. And that's saying, hey, we have no sign change here. We have no where they cross each other. Okay. So that case, we were okay with the no solution. All right. Let's jump down here and do our next one. We're going to put in our y equals our y1, put the 4 times x to the 4th minus 3, and the right-hand side we'll put in our y2. Okay. So y equals, oops, I got to get rid of this error message. Y equals clear, and then simply put in 4x. And if you're looking for an x to the 4th button, there are some other options, but anytime I have a exponent other than squared, use this caret button. It's the little arrow up button, not the ones up here, but the arrow button here. And you can see it gives us a spot to put in the 4. Then arrow out of it. If you press -3, it's going to put that up there. Arrow out of that and do -3. That's our y1. Our y2, we're going to put 2x plus 1. Press enter. Now, if I press graph here, I'm still at that other mode where I was really high and really low. So make sure we go zoom 6 again. And there you have it. You can see we have our y1 is the parabola type shape, and the y2 gives us a line. Do you notice something we haven't seen so far? There are 2 solutions. There are 2 intersections here. Okay. One of them is to the left and one of them is to the right. So let's go ahead and find those. So we've done this enough now. We kind of zoom through. Second calc 5 intersect. Blue one, yes. Red one, yes. Press enter. And it gives us this. It says that right here, x equals -0.867. Does that mean that the other one is this -0.73942? No. Oh, should I just arrow over to it and see if I could find that point now? Think if I get on it, I'll be able to tell what that point is? No, this isn't like Desmos. Okay. So when you have 2 or more, we're going to get maybe 3 solutions. There will be some on the test. I guarantee you there'll be a 3 solution on the test. You have to get that second one. If we keep doing this over and over again, it's going to stay on this point. Okay. But we need to move closer to that. So watch what happens when I go second calc and 5 this time. Instead of leaving this over here next to this point, use these arrow buttons and move your little Crossy Road or Frogger type guy, move them over close to this one. You want to, it's always going to choose the intersection point that is closest. It's not going to go first one, second one, third one. Okay. Then when you press enter, see, this time the red one kind of stays right in there. I think I'm just going to stay with that and not move it at all. press enter and enter, and it gives us our second one as x equals negative 1 point, or not negative, sorry, this is a positive 1.117. Okay, got it? All right, let's take a look at our next example. Let's go into our y equals, clear this out, and we're going to do x cubed minus x plus 1. And what's our second equation got to be? Just 0. Clear that out first. 0. Oh, I didn't jump out of that, did I? I was not paying attention. Thanks for catching that. So yes, this is not going to be too good for me. So let's delete, 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 delete. And now arrow out and put the minus x and then plus 1. Boom. Okay. Zoom 6. I see an intersection. Do you see an intersection? Yeah. Okay. So y1 is this guy. y2 is that guy. And if we go to second and calc, come on, there it is. Oops. Try this again. Second and calc. Intersect, enter, enter, enter. It tells us that what? That x equals negative 1.1 or 324. Now, before you say, hey, I got it, I got it, I got it, I do want to show you another option that we have. If we have solved this for 0, we have 0 on this side. When we have 0 on that side, what we can actually do is go in here and look at these options again. Okay, rather than intersect two equations, what we can do is option number 2. So we can use this intersection or we can go ahead and solve this or solve for the zeros by using the calc and option number 2 to find the 0. All right, now this is a little bit different. I do want to show this because we will be using this more later on. This is kind of optional now in this one, only on a few rare occasions. But I do want to make sure we understand this, okay? So when we do this, we're trying to find out where this crosses the x-axis. Okay. And what we need to do is we need to show it specifically where we want it to look for those spots, especially if it were one that may have had 2 or more intersections. It wants you to be specific on which one. So you'll see down in the lower right left-hand corner, it says left bound. What we want to do is make sure that this is, in this case, below the line of scrimmage, or the x-axis line of scrimmage. Woo-hoo. Talking geometry again. So once I get it to here, I'll press enter, and you'll see it lights it up, and it says, hey, this is the left boundary or left fence. Now I'm going to arrow, watch it move up, and I want to make sure that my y value is positive, that I'm above the x-axis. Press enter, and it gives us this one over here. Again, it wastes some time by saying guess. We're not going to waste time. We're going to press enter, and it jumps right to here, and it gives us that same exact value of x equals negative 1.324. That is that point right there. Okay. We're all good with that? Wow. Okay. So, in summary, number 1, make sure that you're seeing an intersection. Okay. If you have something that looks like this, and your window is only opened up to this, okay, you're going to miss something over here. So take a look at it. Will there only be one solution? In other words, do you have two linears? Or if you have something with a second degree, third degree, you might have 2, 3, or 4 solutions out of this. So make sure you're opening up to see that. And then check your domain. So you make sure you don't run into those cases where there is no solution, there is no intersection, and you keep searching and searching and searching. I would suggest you make sure you put it in your calculator right, just to make sure. All right, I think you guys are going to blow right through this. There are problems that are no calculator, and there are problems that are saying, hey, go ahead and use that calculator. I would suggest if you are one of those that, hey, I don't have a calculator, maybe ask your study buddy, hey, can I borrow your calculator real quickly and do the calculator problems now? And then, we can let them do the calculator.
What did you do? Once you fix it, what? I just want to change it. Look, no, all you have to do. Press, go,